Hey, this is Chad with GeoPro. I'm going to show you today how to process some data in TBC. This is static data. It was sent to me by a fellow surveyor who was having some issues, so I'm just creating this tutorial to try to help out. So what we have here is raw data. It looks like we've got here two NGS benchmarks. It shows that this is a first order vertical monument. And we are working in state plane coordinate system Florida West. So let's start with a new TBC project. I always use the metric template, especially when working in data sheets. I find it's easier. And then we will set the coordinate system. So again, this was Florida West. In this coordinate dropdown, I always just pick the straight state plane 83. There's also the ITRF, and they look similar. I believe the difference is in the transformation. This has, I think, an epoch associated with it. It's going epoch to epoch, and this is just kind of the straight definition of NAD 83. So, but I want Florida West out of here. I don't really know which. I've seen issues before on data collectors using this one, that there was some sort of second transformation applied. So I always just stick with this one. We'll take a look at it as we go through, and hopefully it's the right one. For Geoid, always pick the latest one, survey quality, and say NAVD 88. This I don't think actually means anything. It's just a text field, kind of more of a note to help you, but you can't put a wrong answer in there. So then we'll hit OK. We'll start by importing in the data sheets. So if I copy that directory, say import. TBC recognizes that these two text files are data sheets. If we say import, you now have 2 points in there. If we expand this down, it shows you this is the text file that it was brought in. And so if we open the data sheet for this, the important thing is that these are benchmarks. So the orthometric height here, 44.895, you can see that's right. The ellipsoid height, 18.851 matches. And then the latitude ends in 39913 and 90751. So those match, and we're saying that this is control quality. I'll trust that the other one's correct. This is, I said, the file that actually brought in. If you click the point, you can see where it's doing that transformation and looking at, okay, what are the state plane coordinates? And if we go down on the data sheet, we see that for Florida Northwest, the northing ends in 093 and the easting ends in 499. So those are right. Let's go ahead and we'll start importing the raw data. So this file that I was sent, the folder has the point name in it and the date, I think, that it was collected, and then the rod height. And there's some issue here with some of these rods were collected, were used with a conventional tripod, which I believe are these ones. And then the other ones, which you can see is 6.562 feet, which is 2 meters exactly, were, I believe, collected with a like a bipod or some sort of fixed height rod. So let's start with this. I've never seen this extension before. It's a .308, and if you look at the dates, that was a 308, this is a 312. So the extension there is actually the Julian date, which again, I've never seen before. But if we click OK, we're going to import this file. He's also sent me the Rhinex file, which if I open that up, it's a Rhinex. We go down, and you can see in this Rhinex file, and all Rhinex files, they're formatted year, month, day, hour, minute, second. So this was at 9 seconds. The next measurement was at 10 seconds. So this is 1 second data, which is always helpful to know. For longer observations, especially static observations, I find that it's better, instead of doing it 1 second, unless you're flying a drone or you need some sort of trajectory data that's very high accuracy, it's better to collect just static data, especially longer sessions, at maybe 15 or even 30 seconds. That extra data is just not that useful. So, so here we have, bring in, and you get the point number, 374B, and then on the antenna tab, it tells us it is a SB80 UHF at 2 meters. That conflicts with this point, or the folder name here. So I've been told that this should actually be measured slant mark measurement, and then the height, according to the folder, was 7.34, and I just type SFT in there. Oops. I think I need to have it be lowercase. FT. Yeah. So you type in survey foot SFT in there, and it converts it automatically. So we'll just go through and enter this. Some of this other information, they're all basically the same. I think Trimble could really simplify this by putting antenna height on this screen. But so again, slant mark to the height. You can see that the data came in. This is the NGS data sheet. This is the observation. So we will import the rest of the data. It'll just take a minute here. Another point, 4-hour observation, 4.5 hour, and slant measure at 7.20 SFT. Okay. Again, the points are just coming in, so it's the same one. They're pretty darn close to that control point. Something interesting here. Okay, so this is at 7.2. This is interesting. I'm not sure if this is I don't think it's duplicate data, but it is the same height. Oh, okay, it's on a different day, but it's because you'll notice that the file I'm importing now has a point number of 0374A. And there's already one of those in there. It's not necessarily an issue, but it will merge these 2 points if I import it this way. So I'm just going to change this to C, just so that we get a third point in there to see the distribution. It'll just make it easier to see what's actually happening here. So, and I typed that in right, 7.20 SFT. All right, so now we have 3 points in there. Let's import the rest of these real quick. This is 5.5 hours. Okay, now this one actually says it's to the slant measure mark. It'll be interesting to see. All right, 6.76. Yeah, the rod height was still not right. 2.065. All right, now that I've imported that, because these two observations were running at the same time, you can now see that there's a baseline between the two of them, which we'll process here in a second. This one again is called 055B. I'll just call it C. 4.5 hours again. Slant height measure should be at 6.95. Now we have two baselines in there. And now that I import this one, that was 5 hours at, again, 6.97. And then we have what looks like maybe the rover data at 2 meters. So if we say this, import it. Now I've been told that this is actually to the bottom of the antenna mount. So I'm guessing that's 0.085A. I'll just leave it the way it is. So 2 meters to bottom of antenna mount. We always collect data, no matter whether it's the base or the rover at 2 meters. We use fixed height tripods. Something like this. These are extremely fantastic. I mean, you set this up, they're a little pricey, but you set them up, you know that your base is always at 2 meters or 1.8 meters, and it's just there's never any variation every time. So all right, these were run at 30 minutes. Okay, so in this case, we would actually use a standard bipod that's, again, at 2 meters, though. There's a little bit in the 10,000ths, but I'll just leave that. So now we get, so we had 2 base stations running, right, on this day, and now we now have vectors to all of these roving points. So we import this. All right, now they're named the same, 0, 0, blah, blah, blah. I'm just going to put a 1 in front of these just to change them just a little bit. So again, by doing this, we're going to see where these points fall compared to these other ones. If they were named the same, they would just merge them automatically, which it's fine if you know what's happening, but if you don't, you really kind of want to be able to see what the data is doing, seeing where points fall. And it's especially helpful if you accidentally have 2 points named the same thing that aren't actually the same point. That can get confusing real fast. All right, so now those points are right near each other. And then one more time, this last set. And we're going to put a 2 in front of them this time. Oops. can always rename points later. All right, so now what we have is for each of the bases, you can see that we've got a group of vectors running out of it. And they're running into each of the rover points. I'm not sure why that's not there. There should be another one there, I think. Oh, where'd the other ones go? There's a 2. There's a 1. Where's the 0? Oh, there's different points in here. So some points were observed twice, and then they added more points, it looks like. So this was called 85C and 85F. I'm sure it's fine. We'll just take a look at it. This is one of those challenges when you're processing somebody else's data that you really don't know what was done out in the field, and it's helpful. This is why we named these points different when we imported them, was because we weren't sure where stuff was going to line up, and now everything is separate. We'll just select everything, go to the Survey tab, and hit Process Baselines. Now, because this is 1 second data and it's several hours, this is going to take probably a few minutes. Something interesting, if I had just brought in this Rhinex data by itself, you can see, well, maybe you can't. Typically in a Rhinex, there's 3 files, and one of them is, let's go back here, we're going to look at a different directory. There's the Rhinex file that has the actual observation data in it, and then there's 2 other files. There's an N, there's the O file is the observation data, the N file is the navigation file. And if that N file is missing or it's not there, which often happens when you download it online, such as a CORS data, then you have to come into TBC and have to do an internet download to get those files, but that's besides the point. So baselines are processing. The key things that we want to look for here is that the solution is fixed and that the RMSs are low. And really, as long as it's fixed, these values are going to be good. So it's finished processing. All of them are fixed. So I don't see any issues here. This is where it'll get interesting. So right now, because we didn't set any of these points, right? These are just random. It's actually the autonomous position that came out of the receiver when it was set up. So this point is actually K049. And if you look at it, it's going to have a flag. It's going to say it's a low quality starting point. So what we want to do is merge these points and give them the actual control value. So what we'll do is we'll just copy that point name, Control C, and then we'll go in here and paste it. And when we do, it's going to ask if it wants to merge those or not. So we say merge the point. Boom, it sucks it down and puts it where it should be. We'll do it with, should I do it all right now? Let me recompute here. All right, so when I recompute, it, based on that shifted position, moves it down there, and it no longer has an error because this point is has control quality settings. So it's a control point. Now, the interesting thing is we select this one and go over and look. It is now computing that point a lot closer to the control point. The other ones were using incorrect coordinates. So let's go down here and we'll change the rest of these. We'll get them all merged together. merge points, and then recompute. All right, so all the vectors are coming out of this one right now. It's been processed. And each one of those observations is going over. And look, we're now in the 5 millimeter range, which is pretty darn good. Now, assuming that the antenna heights were all correct, from the Home tab we can hit Measure. And we do some inverses here to go from this control point to, say, this observation. Horizontally, it's at 2 centimeters. Vertically, it's at 2 centimeters. Let me check some of these other ones too. The furthest one, horizontally, it's at almost 3 centimeters. 1 centimeter vertically. It's interesting that the vertical is so much better than the horizontal. But you can also go down and look at the other ones. Now, we're only using one benchmark here, but it agrees, based on the computation, it agrees pretty well, a centimeter to this other one. Benchmarks shift over time, so who knows what the accuracy, what the true elevation is on these points. But if I copy this and paste it into these, recompute. All right, it's giving me an out of tolerance warning. We can right click and say point derivation report. Resize this. Got a lot of junk open. We can look through down this. Okay, so it used the data sheet coordinates, the northing, easting, and ellipsoid height, to compute the position. That's what that tells us, used to calculate. And if we go down through here, we can see that some vectors, one vector in particular, K049 to K068, measured in the easting 2 centimeters, 7 millimeters, and 2 centimeters. That could be for any number of reasons, but if we go down and look at the other points, those all have flags on them too. Let's see why. It must be because those two don't agree to each other to that 2 centimeter. Okay, yeah, it's horizontal tolerance exceeds the computational settings of 2 centimeters. That is controlled in here, computation, point tolerances. So it's saying, okay, flag a point if the horizontal observations are less than or greater than 2 centimeters here, or 5 centimeters vertically. Now, one other thing there, we can change some computation settings here. So we've got these 2 points, right? And they're slightly different. They're a couple centimeters from each other. But what we can say is, if these things become merged, average their values, which is typically the way I do it. And what that has done then is now it's using this elevation, it's running this vector down, finding it, and then it's doing the same thing, and then it's averaging those two out. So let's see what the difference is between these 2 points. They're now at 1 centimeter horizontally and 2 millimeters vertically. You have the flag up here. Point derivation report to see what's happening with it. Again, essentially what's going on between those 2 monuments, between what is published and what is observed, what was actually measured, there's a discrepancy. And that could happen for any number of reasons. That one of those benchmarks could have been hit by a bulldozer or run over by a truck, and it just shifted things 2 meters in the easting direction, or 2 centimeters in the easting and 2 centimeters in the northing. Oh, it's not even in the northing. The elevation looks good. That's in the distance. So one of these monuments has shifted 2 centimeters, most likely. You could solve that by going out, bringing in cores data. Instead of using these two passive monuments, bringing in a core station and seeing what the difference is, to bring in yet a third, essentially base station. But let's just go ahead and we'll change these and see. All right, so that's 0085D. It'll ask me if I want to merge them. So it merges. If I hit this, it's going to recompute them, and it's going to find the average of those 2 points. So again, if we look at the point derivation report, we've got a couple observations. You can see that it's taking the measurements from K068 and K049 and just averaging them. This one is Echo, or no, Bravo. Yeah, that's weird. So who knows what the right name is on this? But we'll stay with the first file. It's got a news. I think I did something wrong there. Okay, so look, something interesting happened there. We already had, let me undo that a few times. All right, so there's a 0085D in here already. All right, that one's probably supposed to be A. B, C, D. So this one's probably D. This one's probably E. This one's probably F. G. And what I can actually do is I can select both of these and say that's supposed to be 00085G. It'll rename both of them. And then I have to hit recompute and it'll find the average. So that's G. All right, this one's H. Yeah, I don't know why this one's named different, but it's just called H. Wait, did I name that one already? I. HIJ. So now we have our 2 base points, everything down here, named sequentially, and we could do an adjustment at this point. One thing I did notice though when I look at this point derivation report is that it's using the ellipsoid height, northing easting ellipsoid height, and we probably want to be using elevation here. So I'm just going to change this to survey quality. So I'm taking the imported coordinates and I'm saying, okay, this is survey quality, not control quality. And that should force the program then to constraining the orthometric height in the computation. No, it's still not. Let's try it one more time. Yeah, still not doing it. I think it would be. That's interesting. All right, so let's do Recompute one more time. I hate seeing these flags. Sometimes they're unavoidable. You could get rid of them, not get rid of them, but hide them by changing that point tolerances to saying 25 centimeters, just making it a larger value. Boom, they're gone. We could also run an adjustment. Let's see. Survey, adjust network. Let me check one thing first. He sent me values on these. I'll check that and I'll come right back. Okay, so I was given these values here by the surveyor. He leveled through the points and derived these, and I wanted to compare them to what the GPS values are. So the first thing I did, I came in and converted. He's working in feet, I'm working in meters, so I just came in and set the display units to US survey foot, and then changed the precision. And what you get is, okay, so these are his leveled values. This is my GPS calculation. And you can see, and then the average. There's a consistent 0.78 feet vertical shift centered around that. Interesting thing is though, right now, all right, so I've got this K068. I've got the coordinate. I've set the status to enabled as check. And then I did a recompute. And now if I look at the point derivation report, it is using the observation from 49 to 68, and it's holding that, saying, okay, this is that observed coordinate is the correct one, and it's comparing it to the local coordinate. And you can see that it's 700ths in the easting, 200ths in the northing, the 400ths in vertical. Pretty good. But I have a feeling that that there's a mistake here, and it's a 78.78 vertical error, and it's happening at both this base and this base, and it's causing that shift in the resultant rover points. And I'm guessing where it's happening is right here. So this is the observations of the bases, and we're saying that this is the antenna height, and I'm guessing that the error is from this. We're saying it's based on this receiver model, the SP80 UHF. it only gives us certain methods of saying where we measured to. And he said that he measured to the mark on the side of the receiver. I assume that meant slant mark, but now I'm not so sure. I'm guessing that probably, I don't know, there's some error here, and it's the error is about 78 hundredths of a foot. Look at, there's my YouTube history. SV. Yeah, I don't know. I don't know where that error would be coming from. Internal UHF antenna. If it's got some sort of special, I wonder if it's got some sort of extension on it that's making up that 7/10 of a foot. I'm guessing that's the issue. But either way, if you look at this and can figure out, okay, where is that 8/10 coming from, let me know and I can provide. All right, after looking at this, I'm guessing, I don't know if this is right, I'm just going to check this real quick. If I look at this occupation spreadsheet, which you can get to on the survey tab, and right now these are all set to slant mark. If we change that instead to bottom of UHF extension, changes will delete processing. This is going to be necessary, but we're just going to check this. Yes. So we're just changing it. So, because I got a feeling that's 8/10 of a foot. All right, by changing the antenna height method measurement, it just removes all of the processing. But I'm going to run this baseline processing again real quick and see. Yeah, continue. It's taking its time. All right, so that finished processing. Just gonna see what my hunch is like here. So basically what I've done is I've increased both of these rod heights because it's now being measured from, instead of the, we said it was going to the mark. It was 2 meters or whatever, 7 feet to the mark, and now we're saying it's 7 feet to the bottom of this special internal antenna extension, like here. And I'm just guessing that that mark to there is actually what was measured, and that's about 8/10 of a foot. So let's just go down here and we'll check. So now it says it's 163.33. 163.09, 164.45. It's still not quite right. 161.63. 161.28. 155.43. 150.96. 147.27. 147.12, and last one is 145.80. Interestingly, you know, those last couple got pretty darn close. Now we're still at 0.14 feet vertical difference, but we're getting closer. Again, it makes me wonder if maybe this isn't right also. I'm guessing 2 meters is right, but this bottom of UHF extension, I'm just not sure. And maybe if it was being measured at a slant, you know, if it was going around the conventional tripod, who knows? Either way, this is a long video, and I hope it's been helpful. There's some issue here, but I'm just not sure what it is without talking to the field surveyor. So, hope it's been helpful. Thanks.